Zwicky's disappearing galaxies. The Coma cluster contains thousands of galaxies, yet observations show that nearly half of its expected luminous matter is completely missing. Fritz Zwicky first noticed this discrepancy in the 1930s when he calculated that the visible mass of the galaxies was insufficient to hold the cluster together via gravity. Gravitational lensing confirms that a massive amount of matter exists in these regions, bending light from distant objects, yet telescopes detect nothing but empty space. This invisible force, now known as dark matter, provides the gravitational glue that prevents the cluster from flying apart. Without this unseen substance, the galaxies would have drifted away from each other billions of years ago. The sheer scale of this missing matter suggests that what we see in the universe is only a small fraction of what is actually there. Hanny's Voorwerp. Hanny's Voorwerp is a colossal, glowing green structure that stretches over 10,000 light-years across the space near galaxy YC 2497. This strange object is not a galaxy itself, but a massive cloud of gas, illuminated by a phenomenon known as a light echo. Approximately 100,000 years ago, a supermassive black hole in the neighboring galaxy acted as a quasar, emitting a beam of intense radiation that struck this gas cloud. Even though the quasar has since shut down and gone dark, the light from that ancient event is only now reaching the cloud from our perspective. The vibrant green color is caused by ionized oxygen atoms glowing under the influence of that prehistoric radiation. It acts as a cosmic time capsule, allowing astronomers to study the past behavior of a black hole that no longer appears active. This ghost-like structure provides a rare visual record of high-energy events that occurred long before human civilization began. NGC 1277. The galaxy NGC 1277 challenges the fundamental laws of galactic evolution because it appears to contain almost no dark matter. In a typical galaxy, dark matter accounts for the vast majority of the total mass, providing the necessary gravity to keep stars in stable orbits. NGC 1277 is a compact elliptical galaxy where the central supermassive black hole makes up an unprecedented 14% of the total galactic mass. For comparison, most galaxies have black holes that account for only about 0.1% of their mass. The absence of dark matter in such a massive system suggests that it may have been stripped away during a violent encounter, or that our current models of physics are incomplete because the galaxy is composed entirely of ancient stars. It is considered a relic from the early universe that has remained unchanged for over 10 billion years. Tidal tail dwarfs. Tidal tail dwarfs are small, newborn galaxies that form within the massive streams of gas and stars stripped away during galactic collisions. When the Andromeda galaxy interacts with smaller neighbors, the immense gravitational pull creates tidal tails that can stretch over 100,000 light-years into the void. Within these elongated ribbons of stolen material, gravity begins to clump gas together, triggering a burst of new star formation. These recycled galaxies are unique because they lack the dark matter halos typically found in older primary galaxies. They represent a rare instance of cosmic birth resulting from the destructive interaction between two larger entities. As these dwarf galaxies stabilize, they begin to orbit their parent galaxy as independent satellites, carrying the elemental signature of the collision that created them. Heidelberg's superspiral. The Heidelberg superspiral is a structural anomaly that defies standard models of how galaxies grow and evolve. It is 10 times more massive than a typical spiral galaxy, containing approximately 700 billion solar masses of material. Most massive galaxies in the universe are elliptical and featureless, as spiral arms are usually too fragile to survive the mergers required to reach such an immense size. However, this object maintains a perfect spiral structure despite its overwhelming scale and density. Current galaxy formation theories suggest that such a massive system should have collapsed into a different shape or depleted its gas reserves long ago. The sheer volume of star-forming gas still present in its arms suggests a history that scientists cannot yet explain with existing simulations. Rubin's Vase galaxy pair. Rubin's Vase is a unique galactic pair where two spiral galaxies are perfectly aligned face-on from our perspective on Earth. This alignment creates a stunning visual symmetry that is estimated to occur in only 1 out of every billion galactic pairings. While they appear to be touching, they may actually be separated by vast distances, creating a rare foreground-background overlap that allows scientists to map the dust in the closer galaxy. If they are physically interacting, they are performing a complex gravitational dance that has yet to distort their elegant spiral shapes. This configuration provides a perfect laboratory for studying how light passes through galactic disks and how interstellar matter obscures more distant objects. The precision of their alignment is so exact that it resembles a singular, more complex celestial body at first glance. Green Pea Galaxy. Green Pea galaxies are small, round, and exceptionally bright objects that were first identified by citizen scientists through the Galaxy Zoo project. Despite their compact size, they are undergoing undergoing an intense starburst phase, producing new stars at a rate that is hundreds of times faster than the Milky Way. This extreme productivity makes them glow with a distinctive green tint, caused by the intense radiation of young stars ionizing the surrounding oxygen gas. They are considered some of the youngest and most primitive galaxy types still active in the modern universe. Because they are so efficient at converting gas into stars, they provide a window into the conditions of the early cosmos when the first galaxies were forming. Some researchers believe these tiny powerhouses may be fueled by baby black holes that have not yet grown to the massive sizes seen in older galaxies.